Hi everyone, my name is Victor Palacios, and today I'll be covering feature selection, which has come up a lot recently in my data science interviews. So for the agenda today, I'll be covering the business and data science perspective of feature selection, some common techniques, and an uncommon technique which I really like. So why feature selection? I found that this is a great topic in terms of both the business side, figuring out why your models are working and how do you explain that to others, and also the data science side, just getting to know what is making your model give you the predictions that it's giving you, and how are those features impacting your accuracy score or your ROC score. So this is John Elder, and he was at the 9 Fall Summit of 2020, in which he says that clients love interpretability, and he is a major player in the data science consulting field. So he has dealt with many different people and figured out that they do love to have some ability to understand what's going on under the hood. As well, in that summit, Michael Berthold, who is the CEO of NIME, says that interpretability is trending. And Dean Abbott, another major player in the data science consulting field, says that interpretability builds confidence with the business side, with the clients. And so you can see that in order to get to an interpretable model or an explainable model, we have to understand the features and how they work and how they impact our predictions. And so we want to be able to say X feature, gives us a plus 10% accuracy. And when we can explain that to the business side, then we kind of get their trust. And the more willing they are to trust our thoughts, the more willing they are to use our applications of data science. And so that's the business perspective of feature selection and why it's important. But from the data science perspective, what are we getting at when we say feature selection? Well, we really want to find features that have big impact on predictions. So I want to know, what is that feature that's giving me a better ROC AUC score, for example. And so I'll talk about some techniques that we can use to figure out what predictors or value variables or features are helping you. And so to do that, I kind of wanted to read up on some articles that had already been written by people who are more senior in the field. And so this article has about 10 different features, not just on data dimensionality reduction, but also on feature selection. As well, if you're more into textbooks, this is a textbook which covers some of the topics in feature selection, as well an introduction to statistical learning is nice. So I would recommend these if you want to do some follow-up work. And so I like to think of the techniques in feature selection in two different ways. I like to think about the dependent on the model techniques. For example, shallow trees depend on decision trees. And in particular, what we do is build a random forest. And that random forest has 2,000 decision trees. And those decision trees are shallow. They only have 2 levels, 3 predictors. And what we're trying to do is find out which predictor, which feature is partitioning the data best. And then we rank by that. So this feature partitions our data best most often. And so it has a high ranking versus those with low rankings. As well, you might want to try things like backwards or forward selection, where you have an empty model, a null model, and you put in one feature at a time and keep going until you don't see an improvement in the metric of your choice. You can also do backward selection, where you have a full model. And what you're doing now is removing features. And you're checking, when is this helping to remove features? And that's model dependent, but we can also think about model independent techniques as well. For example, correlation is 2 numerical variables. We check if they're highly correlated, let's say above 95%. And if they're highly correlated, this can cause overfitting, which we don't want. So we would remove one of these features or variables. We can also do the same thing with chi-square, but this is for 2 categorical variables. As well, if we're looking at categorical versus numerical, we can look at t-tests. So if you have churn as your category that you're trying to predict, and you have some numerical column, like, for example, number of minutes that the customer spends on the phone, and we can say that we hypothesize that maybe the number of minutes that people who churn is less than the people who do not churn. I can run a t-test on that, and if there is significant difference there, that means that a predictor could help us later on in getting better accuracy scores or getting better ROC AUC scores, because it can differentiate between these 2 types of people, the churn or the not churn. If we're not so interested in interpretability, but we do want to reduce the number of features we have because we just have too much correlation, we can do something like PCA, which will take hundreds of thousands of features and reduce them into components. And you can say maybe 10 or 100. You can set the number that you would like of components. And these components are ranked by their variance, high variance coming first, and then you get lower and lower as you move down through the components. And so this technique is nice, but you will lose interpretability, right? Because if I take peanut butter and jelly, put them together, that's PB and J as my component. But usually in the real world, this is not the case. We have maybe 1,000 columns, and then they come together to form this new component. Well, what is that component? What do I call that component? Which is composed of these other features. So now I'd like to talk about an uncommon technique, which I like because it has really an easy way to grasp. And it's good because when I'm explaining that to a business person, they're going to be like, yeah, I get that. And they're going to want to trust me more because they understand this technique. So I had some criteria for choosing this, this one method that I like to present, no matter who I'm talking to. And that's, I want interpretability. I want it to be fast, and I want it to be simple. If possible, well, I also wanted to look at something model agnostic, which is to say I could use a random forest and a linear regression and a decision tree, and I could use this same technique in order to figure out what variables are important. And so for that, I chose permutation importance. It's really neat because all you have to do is you take your x's and you just shuffle one of them. So you shuffle one feature and you check how that impacts your metric of choice. So let's say I have accuracy at 90% without shuffling. I shuffle one of my columns. I see that accuracy doesn't change. This implies that that column, even if I lose the information in that column by shuffling it, it doesn't impact accuracy. So that means it's probably not a good predictor. We can drop it. On the other hand, if I notice that accuracy goes from 90% to 60%, I know that when I lose the information in that column, then I take a hit to my metric. So that column is probably important for prediction. Now, there are some small problems here. The first tiny problem is that you can generate nonsense. So you might recognize this fun type 1 error where a doctor tells his male patient that he's pregnant. And you can do the same thing with permutation importance, right? If I shuffle a column and that column is gender, and I have another column pregnant, then I might end up with a male shuffled who is also pregnant. And this is nonsense that you may not want in your data. So a simple solution there would be to restrict how you permute the data. Another tiny problem is what I like to call correlation corrosion. And this is a simple way of saying that if I have two highly correlated columns, it's going to impact my feature importance in a negative way. It's going to give me slightly skewed answers, and that's not good. So what happens is if I have height at age 10 and I shuffle it, but height at age 20 is, let's say, 100% correlated with that column. The whole point of permutation importance is to lose information in a column. But if another column is highly correlated with it, then that information is actually preserved in that other column. So I haven't really lost the information, and therefore my permutation scores will be off. A simple remedy is in a pre-processing step earlier, you can remove highly correlated variables, or if you're not sure about removal, what you can do is permute two columns together or multiple columns together if they're highly correlated. But there is a not so tiny problem, and this problem is not unique to permutation importance, but it is important to be aware of. And that's the fact that we're only looking at one kind of information at a time. So there might be gender and there might be height, and I only look at what happens if I shuffle height, or I only look at what happens if I shuffle gender. But what happens if shuffling them together leads to some new result? So let's say, for example, that I am trying to predict whether a house is desirable. This is binary 1 or 0. And I look at some variables like price, longitude, and latitude. I do permutation importance, and I find that price is more valuable, better predictor than longitude and latitude. But this is only when I'm looking at price alone, or longitude alone, or latitude alone. But in the case that we combine longitude and latitude, which becomes location, we might find that price is not as valuable as these two combined. So this is a kind of subset analysis, which we typically don't do because it's very computationally expensive. And so much, much slower. And so I began this talk by saying that interpretability builds confidence. And what I like to end with is that feature selection is our way to create trust with the client. And so once we've built trust with the client or with the business side, they're more likely to take more ideas from us, more likely to put our models into production. And so that's why this topic is so good for interviews. And so if you have any questions, please leave a comment below, and I will have some links available for the sources that I mentioned. Thank you so much. Bye.